Hello everybody, I'm geologist Taylor. Welcome to another sunny, hot day here in the Mojave Desert. Today we're at Fossil Falls. Come with me down the trail and let's see what it's about. The ground I'm standing on is fairly flat, and that'll change pretty dramatically just up the trail. But there's one thing you probably notice all around me and what's in my hand. This rock is basalt, and it's what composes Fossil Falls just up ahead. This rock is extrusive, meaning it forms above the surface, and if we look closely, as I'll show you here in a few minutes, it's filled with a whole bunch of tiny holes. These are what we call vesicles, or gas bubbles, that pop whenever gas escapes from the molten lava. Fossil Falls is just off of 395 on the eastern side of the Sierra Nevada mountain range. The basalt all around me, you'll start to notice as you drive up 395, you'll start seeing little pockets of this black extrusive basalt on the side of the road. All of this basalt, including the basalt that makes up Fossil Falls, originated from my right, or more accurately the northeast, from the Coso volcanic lava field. Now, the lava that makes up this basalt as you drive up 395 in Fossil Falls started erupting about 400,000 years ago up until about 10,000 years ago, when Fossil Falls itself started to be sculpted and molded into these falls that you see today. Now, of course, this is called Fossil Falls, and if you look around, it's obviously very dry, and there aren't fossils. This is basalt. We're not going to find fossils in these rocks. But why it's called that, of course, is because this is a fossilized waterfall of sorts. Back behind me is the head of that waterfall. And so typically as waterfalls form, they start to erode back. And so this whole valley that we're seeing is that waterfall as it moves all the way back into its current position. And so while Fossil Falls, while there's neither in this area, it is a fossilized waterfall of sorts. Let's get up close and personal with these basaltic rocks before it gets too hot. If you look closely, you'll notice these holes in the rock. These are what we call vesicles, or more appropriately, rock burps. As the rock starts to cool, it starts releasing gas, forming these little pockets that you see all over. When we go up to the top of the waterfall, you'll notice that the rock is going to be very smooth. And because of the way this valley was formed, it's formed from that water erosion. So that's going to give it this nice, smooth, polished texture that we're going to see here in a little bit. So we know the lava, the basalt that forms Fossil Falls, stopped around 10,000 years ago. But when did all this stuff started being carved out, forming these waterfalls? Well, that started after the last glacial maximum in the Sierra Nevadas about 10,000 years ago. So we've talked about the lava field, the Coso volcanic field, that produced this basaltic rock that enabled Fossil Falls to be formed. But of course, once we have the rock, that rock has to be eroded by something. And in our case, just behind me, the Sierra Nevadas provided that glacial meltwater to do so. And this all started about 10 to 20,000 years ago as those glaciers started to melt and run off. And evidence of that meltwater can be seen today. As you drive up 395, you'll start seeing little pockets of small lakes. Even the Owens River is a remnant of this. But that same glacial meltwater made its way over the Sierra Nevadas down to Fossil Falls and started carving through this basaltic rock that covers the east side of 395. So clearly there's some cool geology on this short roadside stop as you're going up 395. But you can hike out here. There's plenty of it down right behind me in this valley and all around through this volcanic lava field. And at night, when it gets dark, if you look up in the night sky, you'll see plenty of stars all around you. And hiking, camping, and nighttime photography and stargazing aren't the only activities you can do. With these sheer rock walls, makes it a popular place for climbers in the area. And as you walk around through the lava field and down towards the trail into the valley, you'll notice anchors that climbers use to get up and down these sheer cliffs. If you get up to the head of this waterfall, you'll start noticing these circular features in all of the rocks. And while we do still see vesicles on these rocks, they are a little bit more polished and a little bit more rounded up in these headwaters. But these circular features that you see are what we call potholes. These are when water starts rushing over the head of the waterfall, carrying a bunch of sediment and in some cases chunks of rock that get entrained and start essentially digging out and cutting out some of these pieces of rock. And so we have these potholes that are carved out from water and sand and rock all into one, carving out these basaltic features. We also have these long straight features on top of the basalt that is formed much in the same way, except for this just comes from sand and finer silts in that water rushing past and acting as sandpaper against that basalt. From these straight features, we can interpret a flow direction. And while we might not need it here at Fossil Falls because we have this massive canyon helping us, if there were any ambiguity to it, we could look at these straight features and show that the water was flowing from the northeast down towards 395 towards the south. Thank you for visiting Fossil Falls. I'm geologist Taylor. Please like and subscribe below and hit that bell icon for notifications for new episodes each week. See you again.